What does your company do?
We manage the supercomputer infrastructure across Western Canada and the high-speed research and education networks. And we're working with some very big data projects, so we're fascinated to see if there's some interesting leads and ideas at the conference this week, and I'm sure there will be.
So when you say a big data project, what do you mean?
One of our projects is building something called the Square Kilometer Array, which is the largest radio telescope in the world. It'll produce a petabyte of data per second, 24/7, when it comes on stream some years from now.
A petabyte a second. Yeah, I'd say that qualifies as fairly big data. So what kind of infrastructure do you need to handle that?
Well, obviously we need great big network pipes. We need to understand how to analyze that data. Fundamentally, that's intractable to the human intelligence, so we need to be developing artificial intelligence agents to get inside those data sets. It's an interesting problem. Fortunately, we have a little time to work on it.
How much time are we talking about?
About 8 years.
About 8 years, okay. So if I thought about it in my rather crude way compared to what you're considering, I'd be thinking about moving bits and bytes around, storage, and then the processing power itself. Are you building a large grid computer there, or outsourcing the processing and storage? What's the approach?
The approach is to really, at the moment, it's a research stage. The analogy from hockey would be trying to get to where the puck's going to be rather than where it is right now. We have to imagine some technologies that are going to be available to us at the time the telescope comes on stream. So big pipes, but finding new ways of moving data or finding ways to not have to move data are just as important.
So when you think about moving to where the puck is going to be, as you say, a fantastic Canadian expression, and actually not just Canadian expression, I think Wayne Gretzky probably brought that to the rest of the continent too. But as he was too, I think a lot of assists came from that fellow. When you think about that and sort of sharing technologies, what kinds of tech do you think will need to be there in order to do the things that you'd want to be able to do with this project?
So we can't just rely on Moore's Law. That's going to take us only so far, and we're seeing that data storage is coming up fast, but data volumes are going much beyond that. Likewise with processing power, so we do need new technologies, and that's part of the fun, is looking at those. I can't describe to you what those will be because they are fundamentally new. It's not that I'm hiding any secrets, we're still trying to figure out what they are.
What's the stack that you're building on right now?
Oh, we're very much endorsing the use of OpenStack. We've tried other technologies. We're very committed to open source, and we like the fact that that's backed by a good-sized resource with Rackspace. Tried some experiments with Eucalyptus, and just felt that OpenStack was the way to go. So.
Well, I had the opportunity to talk to Chris Kemp, formerly of NASA, now of Nebula Inc., and talked about the industrial strength cloud computing, and it certainly sounds like the scale of scientific data that you'll be working with will require that kind of robustness.
Yeah, and Chris has been a real asset to the whole open source movement around this. He's an eloquent spokesman and a smart guy, and we need more people like that working on the problem.
Well, I think a lot of people would definitely agree in the space. Thank you very much for this. For people who want to learn more about your project and work, is there a website or particular article I can turn them to?
Sure, Cybera.ca, not .com, but .ca is a good place to find links to our work.
Fabulous. Thank you very much for your time, and I look forward to seeing you more over the course of the week.
Thank you.
Thank you.